Welcome sa course na Engineering Mechanics, particularly Statics of Rigid Bodies, kung saan nadi-discuss ngayon yung introduction ng Engineering Mechanics. Define natin yung mechanics. So, based sa isang reference, so mechanics is a branch of science dealing with the state of bodies at rest, in motion, or resulting in deformation when acted upon by a force system. So, ano yung maging reaction ng mga bodies kapag meron na apply na force or force system? Upon applying a force system to a body, at least one of the following outcomes may occur. The body may move if there's no adequate restraint, or it may not move, but noticeably deform. Generally, if the deformation is noticeable, then it is discussed under deformable body mechanics, often called strength of materials or mechanics of materials, na susunod na course after ng statics at dynamics kasi may analysis doon na kailangan may knowledge ka muna sa statics para ma-solve or maintindihan. If the deformation is negligible or no movement occurs, then it is discussed under rigid body mechanics. So both are divided into two areas, statics and dynamics. So statics deals with bodies at rest and dynamics deals with bodies in motion. The branch of mechanics that deals with liquids or fluids in general is called fluid mechanics. Ito naman yung sa isa pang reference. So engineering mechanics is basically a branch of mechanics associated with the study of effect of forces acting on rigid bodies. So such forces may keep a body or bodies in rest or in motion. So if a body remains in rest conditions, it means that the net effect of all forces acting is zero. So kung naaalala pa sa physics dati, yung laws of motion, so kapag yung total forces or yun nga dito, yung net effect ng all forces, so ay hindi magkakos ng motion sa isang object. So, ang term natin doon ay static or yung body na yun is in equilibrium. So, however, if the body moves, it means an unbalanced force is acting and causing the motion. So, this condition of body is termed as dynamics. So, thus, engineering mechanics is mainly concerned with the effect of forces on rigid body. However, mechanics is broadly classified into various categories depending upon type or nature of bodies influenced by forces, and the bodies may be solid or fluid. So, ito naman yung mga divisions ng mechanics na nabanggit kanina. So, una, kung ano ba yung ina-applyan ng force, kung solid ba or fluid. Kung solid, kino-consider ba yung solid as rigid or deformable? Kung rigid body, at rest ba or in motion yung ina-applyan ng force. At sa course na to, mag-focus tayo or ang pag-aaralan natin yung solid na i-consider natin as rigid body na at rest or in equilibrium. Sa isang reference pa, ito naman yung importance ng pag-aaral ng mechanics. So, halos lahat ng discipline ng engineering at some point may encounter to. So, the purpose of mechanics is to explain and predict physical phenomena and thus to lay the foundations for engineering applications. You need to know statics to determine how much force will be exerted on a point in a bridge design and whether the structure can withstand that force. So, determining the force a dam needs to withstand from the water in a river requires statics. So you need statics to calculate how much weight a crane can lift, how much force a locomotive need to pull a freight train, or how much force a circuit board in a computer can withstand. So malalaman dito sa course na to yung mga concepts para mas lalo nating maintindihan at masolve yung mga problems na nabanggit na yan. Ito naman yung mga terms or concepts na dapat munang malaman bago mag-proceed sa pag-aaral ng statics of rigid bodies. Una yung space. Space is the geometric region occupied by bodies whose positions are described by linear and angular measurements relative to a coordinate system. For three-dimensional problems, three independent coordinates are needed. For two-dimensional problems, only two coordinates are needed. So, more on 2D analysis naman yung i-discuss dito. Pero may part na may 3D din. Depende na lang kung intuitive yung mga magiging problems. Para malaman natin kung madadalian ba tayo or medyo may hirapan. Kasi nga, medyo confined yung pag-aaral natin sa 2D plane ng screen at reference materials. Pero sa part ng 3D analysis, husayan na lang natin yung pag-aaral doon. Next ay yung time. So time is the measure of the succession of events and is a basic quantity in dynamics. So time is not directly involved in the analysis of static problems. So sa statics, dahil nga walang motion, hindi rin magagamit yung time. So part to ng dynamics, so importante to doon. So mass is a measure of the inertia of a body, which is its resistance to a change of velocity. So mass can also be thought of as the quantity of matter in a body, and the mass of a body affects the gravitational attraction force between it and other bodies. So this force appears in many applications in statics. Tas yung force is the action of one body to another. A force tends to move a body in the direction of its action. The action of a force is characterized by its magnitude, by the direction of its action, and by its point of application. Yung force at mass, yung karaniwan na may encounter sa course na to. Kasi nga, interaction to ng dalawa kung ano yung effect ng force sa isang mass or matter. At yung particle naman, may mga problem na kinoconsider na yung ina-analyze yung mass concentrated to a point lang. Kumbaga, hindi naman makaka-apekto sa analysis yung size, kaya kinoconsider lang siya as particle. At rigid body naman yung object kapag yung internal deformations ng isang material na ina-applyan ng load, sobrang liit na or negligible na para malaman yung external force na nag-act sa material na yun. At yung length is used to locate the position of a point in space and thereby describe the size of a physical system. Once a standard unit of length is defined, one can then use it to define distances and geometric properties of a body as multiples of this unit. A concentrated force represents the effect of a loading which is assumed to act at a point on a body. We can represent a load by a concentrated force, provided the area over which a load is applied is very small compared to the overall size of the body. So an example would be the contact force between a wheel and the ground. So may encounter din natin to, maraming concentrated force dito sa statics. Kumbaga, kinoconsider na lang natin na nag-act yung force sa isang point sa part ng body or ng matter or ng mass. Units, kasi nga may mga problem solving dito. So kaya kailangan natin ding i-define yung mga units na pwedeng magamit. May dalawang type ng units. So fundamental or base units. So examples, length, time, at mass. At derived units, galing to sa mga fundamental or base units gaya ng force, work, power, density, area, volume, velocity, and acceleration. So system of units, sa pag-solve ng mga problems sa statics, pwedeng may isang system of units na gamitin or pwede rin i-convert from one system of unit to another. So ang importante, familiar tayo sa mga to. So MKS, so meter, kilogram, second. So MKS, VGS, centimeter, gram, second. And then FPS, so foot, pound, second. So yung tatlong yun, nakadepende yung pangalan nila kung ano yung mga unit na ginagamit. So length, tapos yung mass, at saka yung time. Yung FPS din, yun yung USCS or US Customary System. And then yung SI naman or International System, so yun yung karaniwang ginagamit sa halos lahat ng non-US reference na pwede nating makuha. So pero meron pa rin namang nakasanay ng gumamit ng FPS or US Customary. Sabi ko nga yung importante sa mga units na to, so familiar tayo at alam natin kung paano i-convert from one system to another. Sa SI units, ito naman yung base units. Meron dyan, may encounter sa statics or dynamics. Tapos yung supplementary units. So may mga derived units na may distinct name. So yung Newton, Hertz, so Watt, Pascal, Joule. So may mga derived units din in terms of base units. So for acceleration, yung meters per second, and so on. No? Kasing symbol din nakalagay dyan. May mga may encounter kayo dyan sa kahit unang part pa lang ng statics. So, importante nga, familiar tayo sa mga units na to. So, gumagamit din ng prefixes kapag sobrang laki or liit ng values na nasolve sa problem. So, sa calculators, ito yung mga prefixes sa ENG or Engineering Notation. Ito yung karaniwang ginagamit. So, yung una, yung 1 billion, 10 raised to 9, times 10 raised to 9, so giga or G. times 10 raised to 6. So, mega or malaking M times 10 raised to 3. Kilo or maliit na K times 10 raised to negative 3. So, milli times 10 raised to negative 6. So, micro. Tapos 10 raised to negative 9, nano. So, engineering notation to dun sa calculator na pag ginamit nyo, ito yung mga lalabas. 369 or negative 3, negative 6, or negative 9. So, next ay yung scalar and vector quantities. So, simply put, ang scalar, magnitude lang. Ang vector, may direction. So, example ng scalar is mass, length, volume, power, temperature, and time. That's a vector. Force, weight, moment, couple, displacement, velocity, acceleration, and momentum. So, may mga terms dyan na baka ngayon nyo lang na-encounter, pero throughout the course naman, maiintindihan natin itong mga to. So, next part ng lecture, mag-analyze na tayo ng vectors doon. So, ang notation para sa vectors, para masabi nating vector, kapag nakasulat or nakatype, pwedeng naka-boldface, kaya dyan yung A, italicized, or kaya naman kapag sulat lang, pwedeng lagyan na lang ng arrow sa ibabaw para sa mga computations na handwritten. So, force, nabanggit na to kanina, pero mag-delve in pa din tayo. So, force, sabi nga, is the action of a body about another body, and it changes or tends to change the state of rest or motion of a body. So, forces exist between an interaction of an object with another object. So, whenever there's an interaction between two objects, there's a force upon each of the objects. So, force is a vector quantity. It depends on the direction as well as on the magnitude of the action. So, force acting on an object may cause the object to change its shape. So, pwede mag-deform, to start moving. So, yun yung sa dynamics. To stop moving, pwede rin sa dynamics, or to accelerate or decelerate. So, sa statics, kailangan yung mga forces nag-act dun sa object para makonsider natin siya as in state na static, dapat in equilibrium or zero, no, yung total net force acting on an object. So, as shown in the figure below, the effect of the force applied to the bracket depends on P. So, yun yung karaniwang notation ng force dito sa statics or kahit sa dynamics. So, the angle theta, yung angle natin pwedeng relative dun sa horizontal axis or vertical axis, yung pagme-measure. So, dito, relative dun sa horizontal axis. So, and the location of the point of application. So, doon naman nakalagay kung doon sa bracket. Dahil nga dito, sabi, sa bracket nag-a-apply yung force P. So, saang part ng bracket yung point of application. So, if any of these specifications will change, it alters the effect on the bracket. So, syempre, kapag yung magnitude nagbago, so mababago yung effect nun sa bracket, yung angle theta or yung direction, tapos yung sense, and the point of application. So, yun yung mga characteristics ng force. So, magnitude represents the value of the force. So, the magnitude can be represented graphically by drawing a vector to scale. So, may analysis ng vectors na pwede nating makompute kung ano yung tinatawag na resultant or yung mga unknown. Gamit lang ay pagdodrawing ng vector up to scale. So, pwedeng yung unit nga natin for force, pwedeng Newton. No? So, pwedeng 1 Newton is equal to 1 centimeter kapag in-scale mo. So, yun. Pwedeng i-represent natin siya graphically or pwedeng i-drawing. Next naman ay yung direction. So, direction of the force is represented by the line of action and angle it forms with some reference axis. So, the line of action is indefinitely long line on which the force is laying. So, nakalagay din sa figure kung ano yung direction natin. So, meron kang line of action tapos yung angle. So, sense of the force is represented by an arrowhead. So, kung saan papunta yung force. So, it specifies the direction in which the force moves along the line of action. So, the direction relates to the line of action of the force, and the sense is the way in which the force moves along that line. So, next ay yung point of application. So, it is the exact point at which a force is applied to a body. So, graphically, it is represented by the tip of the arrowhead It may be situated in the opposite end of the arrowhead, and it is unique to each force. It may happen that different forces share the same point of application. So, meron din tayong classification ng force. So, pwedeng contact or body force. So, contact, kapag, so it is produced by direct physical contact of two objects. And they are distributed over a surface of the body. Example ay yung mga applied force, frictional forces, normal forces. So, may encounter natin itong mga terms na to throughout the course. So, body force is produced when body or an object is in a force field such as gravitational, electric, or magnetic field. So, these types of forces results when the two interacting objects are not in physical contact. So, pag may physical contact, kagaya na applied force, frictional forces, or normal force, so contact force. Kapag wala, so body force. Pwede rin naman na i-consider yung force as external or internal force. So, may encounter pa natin itong mga terms na ito, magagamit natin to. So, external force is applied externally to an object. Pwede yun yung mga applied force or reactive force. Kapag nandun na tayo sa analysis ng structures, may encounter pa natin to. Tapos yung internal force naman, developed inside the body to resist deformation of the body. So, para naman to dun sa nabanggit nga na strength of materials or mechanics of deformable bodies. So, forces may be further classified as concentrated or distributed force. Concentrated, nabanggit kanina kapag yung force ay naka-apply lang dun sa isang small point sa isang body. So, concentrated force yon. Kapag naman distributed over an area, so distributed force naman yung tawag doon. So, meron tayong tinatawag ng mga force systems. So, collection or pattern or group of various forces acting on a rigid body. It is of two types, and its classification depends upon number of forces acting in planes. Classification of force system. The force system is classified into two categories. So, coplanar force system tsaka non-coplanar force system. Yung coplanar force system, it is the one where a number of forces work in a single plane or common plane. Kaya nga siya coplanar. So, tulad sila ng plane kung saan nag-act yung mga forces. So, yung coplanar force system, meron pa siyang further divisions. Pwedeng concurrent, collinear, parallel, or non-parallel. So, yung una, yung concurrent, ganito yung itsura niya. So, if a number of forces work through a common point in a common plane, then the force system is called concurrent coplanar force system. Kumbaga may common point sila. Kagaya dyan, yung common point ng force na P1, P2, P3, P4 ay yung O. Next naman ay yung collinear coplanar force system. Dahil nga collinear, so if a number of forces have single line of action, dahil nga collinear, so isang single line of action lang, tapos nasa common plane, kaya coplanar. So yung tawag doon ay collinear coplanar force system, kagaya nung nasa figure. So force 1, force 2, force 3, so single line of action lang sila, kaya collinear. Tapos nasa isang plane. So, coplanar. Collinear coplanar force system. Next naman ay yung parallel coplanar force system. So, yun nasa figure. So, if a number of forces have a parallel line of action in a common plane, so parallel sila. So, parang hindi sila yung collinear, no? Kasi iba to dun sa collinear. Parallel naman, magkakaiba sila ng line of action, tapos parallel, tapos nasa isang common plane din, kaya coplanar. Next naman ay yung non-parallel coplanar. So, if a number of forces do not have parallel line of action in a common plane, kaya nga non-parallel, tapos may common plane, so coplanar. So, ang tawag doon is non-parallel coplanar force system. Tapos yung isa pa, yung non-coplanar force system naman. It is the one where a number of forces work in different planes. So, may subdivisions din to. So, concurrent non-coplanar, non-parallel non-coplanar, tsaka parallel non-coplanar. So, concurrent non-coplanar, kagaya ng nasa figure, may isang common point sila pero nasa iba't ibang planes. So, common point, concurrent, iba't ibang planes, so non-coplanar. Next naman, yung non-parallel non-coplanar force system. So, nakikita naman sa figure na when a number of forces are having different line of action, tapos hindi sila parallel, tapos nasa magkakaibang plane, so non-parallel, non-coplanar force system, kagaya na nasa figure. Next ay yung parallel non-coplanar force system. So when a number of forces are having parallel line of action in two different planes, then the force system is known as parallel non-coplanar force system. Kagaya nung nasa figure, so parallel sila, tapos magkakaiba ng plane. So, parallel non-coplanar force system. So, yung mga yan, iba-iba kasi yung analysis sa mga yan, no? Pero same concepts din naman, no? Para lang kapag na-encounter natin, hindi na tayo magugulat kung ano tong mga to. So, kung ano yung mga force systems na to.